Percent applications. Simple percent problems consist of three possible unknowns. For example, 90 divided by 200 equals 45%. If one of these three quantities is unknown, and if we are given other two, we can easily find third one by rearranging them. So the formula looks like this. Final amount equals percent amount divided by the base amount or the original amount. Percent increase and decrease. Percent increase is basically amount of increase divided by amount before the increase. Percent decrease similarly then is amount of decrease divided by amount before the decrease. Both cases we can calculate them using final amount minus initial amount divided by initial amount. Let's look at some examples. If we need, we will round answers to two decimal places. The first example, a sales representative receives a commission of 12% on all weekly sales. How much must that representative sell in a week so that their commission earned will be $500? So we can do something like this. We can say let X represent the sales. In that case then, we can say then X amounts 12% equals 500. So X times 12%, which is then as a decimal 0.12. So 12% as a decimal is 0.12 equals 500. So if we want X alone, we'll divide both sides by 0.12. So X will be basically then 500 divided by 0.12, which then will end up being 4166.67. And this amount we round to two decimals because it's money. So that person must sell around $4,166.66 worth goods in order for them to receive 500 as a commission. So we can say that representative, therefore, make sure we write therefore statements. Therefore, that representative must sell $4,166.67 worth of goods. Okay. Let's look at second one. The temperature on a warm day rose from 21 degrees Celsius to 25 degrees Celsius. Find the percent change in the temperature and interpret the results. Okay. So we can use this formula, percent increase, because the temperature is increasing, or you can say percent change. It's the same thing. In our case, the change is increase. So percent increase is amount of increase divided by amount before the increase. So in our case, 25 subtract 21, 25.0 subtract 21.0, which is 4, divide by 21, and the amount we will get will be in decimal. So we'll have to multiply by 100 to convert that into percent. So we will get then 19.05, rounding it to two decimal, 19.05%. So we can say the temperature, so let's change the font here. Therefore, the temperature rose or increased by 19.05%, which is pretty high. Okay, pretty high change, drastic change in the temperature. On the other hand, let's say the temperature on a snowing day decreased from 3 degrees Celsius to 1 degree Celsius. Find the percent change and interpret the results. So now instead of increasing, the temperature on a wintry day, on a snowy day, let's say, is decreasing. So we can say percent decrease equals amount of decrease divided by amount before decrease. So in our case, it will be 1.0 1.0 subtract 3.0 divided by 3.0, and again we'll multiply it by 100 to convert that into percent. We'll multiply it by 100 to convert into percent. We will get then negative 2 divided by 3, so that's 6 point and times by 100, so that will be negative 66.67%. That's very drastic change in terms of change. Okay. Temperature wise, it's only 2 degrees decrease. Percent wise, it's negative 66.67%. So we can say, therefore the temperature decreased by 66.67%. I'm not using negative because decreased by already shows it went down. Okay. Let's see another example. After 9 years, an element loses 72% of its original activity. What amount of 150 gram of that element will remain after 9 years? So now it's decreased. We are given the percent decrease and we are given the original or initial amount, and we are looking for final amount. So we can say percent decrease, okay, equals amount of decrease. So in our case, instead of writing formula, I'm just going to go like this. So percent decrease is this. In terms of formula, then if you plug in the numbers, percent decrease will be basically 72% as a decimal, 0.72. However, we'll use negative to show it's going down. Final amount is unknown. Initial amount we know it's 150 grams. Okay, divided by 150. And now we need to find final amount. So we can then say negative 0.72 times 150 equals final amount subtract 150. Negative 0.72 times 150 will give us negative 108 equals final amount minus 150. So it will be final amount minus 150, and then final amount will be then final amount equals negative 108 plus 150, which will then end up being 42 grams. So then we can say, therefore, the amount remaining after 9 years is 42 grams. Okay. Let's see one more. A bacteria culture grows by 160% in 12 hours. If the initial colony has 3600 individuals, how large will be the colony after 12 hours? It's increased by 160%. So let's use the formula for percent increase again. So percent increase is amount increase divided by amount before the increase. So it will be basically then in our example then amount increase is 160%. 160% as a decimal is 1.6. So we will get 1.6. Final amount is unknown. Initial amount is 3600 divided by 3600. So then we can say 1.6 times 3600 will be final amount plus 3600. 1.6 times, or sorry, minus 3600 here. So if we do 1.6 times 3600, which will give us this, and then bringing 3600 to the left or adding both sides by 3600, we get 9360 as the final amount. So then we can say, therefore, after 12 hours, there will be 9360 bacteria These are some word problems, some applications of percent.